So finally, just to touch a little bit on my area of interest, which is end organ or liver damage in the, and why do people die in the metabolic syndrome. In terms of the prevalence of fatty liver disease, we don't have good data from Southeast Asia or Australia, but we do have data from the Dallas Heart Study. And what you can see is that this was about 2,000 patients. Every single one of them had MRS measurements of liver fat. And the normal amount of liver fat by MRS is about 5.6%. And the Dallas Heart Study suggests that the prevalence of fatty liver disease in the general population in Dallas is about 30%. So 1 in 3 have fatty liver disease. We also know about the chronology of fatty liver disease, and these are from Japanese office workers having serial tests. We know that first what happens in the chronology of fatty liver disease, body weight goes up, your HDL goes down, then your triglyceride goes up, and elevated AST and ALT occur at this stage, which is when they get referred to the gastroenterologist. Then they develop hypertension, then they develop the hyperglycemia. So by the time a gastroenterologist sees these patients, they've already got past all of these early stages in the development of the full-blown metabolic syndrome. We also know that fatty liver disease is associated with a standardized mortality ratio that's increased by about 1.5%. And in terms of the cause of death, the cardiovascular disease is responsible for about a third, malignancy about a third, and about 15 to 20% from liver disease. And the liver disease mainly occurs in patients with cirrhosis. What drives liver inflammation in these patients with fatty liver disease? And this is a study that we undertook where we actually measured visceral fat as a percentage of body weight. And what you can see is liver inflammation and liver fibrosis were intimately related to the extent of visceral fat. So as opposed to liver fat and insulin sensitivity in the tissues, when you look at liver inflammation and fibrosis, more than the insulin resistance as measured by the HOMA, it's visceral fat that seems to be the most important driver of inflammation within the liver. In terms of the direct mechanisms of injury in the liver, there's a whole lot of factors that have been studied, and I will just very briefly touch on fatty acids and oxidative stress and a little bit on adipokines. And the question in terms of liver injury is it the fat that's damaging your liver, or is it the free fatty acids in equilibrium with the fat, with the triglyceride, that's actually damaging the liver? And this is a nice study. The MCD diet model is a methionine choline deficient diet. And these animals with the MCD diet develop lots of liver fat, as you can see with the oil red O staining. And what this group actually did was they used antisense oligonucleotide to DGAT2, which is the terminal step in triglyceride synthesis. So the expectation was if you'd reduce triglyceride synthesis, then you should reduce liver damage. And what you can see is when they gave the DGAT2 ASO, you reduced liver fat, as you can see. But in fact, what you ended up happening is you had increased oxidative stress, you had increased collagen deposition, and in fact, you had increased free fatty acids. So liver triglyceride, the one that you see, is actually chemically inert. It's actually protective to the liver. And it's the free fatty acids in equilibrium with this that seems to be toxic to the liver. The other question is it saturated or is it saturated fats or unsaturated fats that are bad to the liver? This is a study, as you know, that saturated fats like palmitate get converted into MUFA by SCD1 and then get synthesized into triglyceride, which we think is inert. And what you can see is if you give palmitate, you have less triglyceride loading than when you give oleate, which is a monounsaturated fat up here. But if you give a saturated fat, you have increased apoptosis and decreased cell viability, and with oleate the cells are protected. And so what this is suggesting is it's the free fatty acids that are bad and saturated fats that are worse than the polyunsaturated fats. The other thing that's been shown that's very important in liver injury is cholesterol loading. And this is an animal model of a choline deficient diet. And if you take hepatocytes from choline deficient diet animals and then you actually treat them with a high cholesterol diet, what you can see is with a high cholesterol diet, there's increased apoptosis, increased necrosis, reduced mitochondrial GSH, and interestingly, in human patients, when they actually did liver biopsies and measured free cholesterol was the only thing that seems to be increased. So it seems to be free fatty acids, saturated fats, and free cholesterol that's important for liver injury. A lot of these things act through oxidative stress, and there are lots of studies now showing that around adipocytes, there's lots of oxidative stress that's causing liver injury. And in terms of the hormones that I was actually talking about before, leptin and adiponectin, this is a study that we published earlier this year where we showed that leptin, which is elevated in people with the metabolic syndrome and fatty liver disease, that leptin is directly fibrogenic to the liver, activating the Kupffer cells and activating the fibrogenic machinery within cells. And then there are other studies that have actually shown the same thing with adiponectin, that if you have low adiponectin, you have increased fibrogenesis in the liver. So I might just stop there, and I hope I've just been able to cover the relationship of the liver to the metabolic syndrome, to insulin sensitivity, to lipogenesis, and finally in terms of the mechanisms for liver injury and liver cell death and cirrhosis. Thank you.